Hello explorers and welcome to another video. It's that time again, it's the best time of the year, it's Advent of Code. Every day during December until the 25th we will get 2 new puzzles every day to solve. Let's start off with day number 1. So let's jump over here to my screen and read what today entails. Sonar sweep. You're minding your own business on a ship at sea when overboard alarm goes off and you rush to see if you can help. Apparently one of the elves tripped and accidentally sent the sleigh keys flying all into the ocean. Before you know it, you're inside the submarine and the elves keep ready for situation. The elves keep ready for situation like this. It's covered in Christmas lights. Because of course it is. And it's even an experimental antenna that should be able to track the keys if you can boost its signal strength high enough. There's a little meter that indicates the antenna's signal strength by displaying 0 to 50 stars. Your instinct tells you that in order to save Christmas, you'll need to get all 50 stars by December 25th. Collect stars by solving puzzles. 2 puzzles will be made available each day in the Advent calendar, and the second puzzle is unlocked when you complete the first. Each puzzle grants 1 star, so good luck. As the submarine drops below the surface of the ocean, it automatically performs a sonar sweep of the nearby seafloor. A small screen, the sonar sweep report, your puzzle input, appears. Each line is a measurement of the seafloor depth as sweep locks further and further away from the submarine. For example, suppose you have the following report. And then they give us a bunch of numbers here. This report indicates that scanning outwards from the submarine, the sonar sweep found a depth of 199, 200, 208, 210, and so on. The first order of business is to figure out how quickly the depth increases. Just so you know what you're dealing with, you never know if the keys will get carried into deeper water by the ocean current or fish or something. To do this, count the number of times a depth measurement increases from the previous measurement. There's no measurements before the first measurements. In the example above, the changes are as follows. And then the first, no previous measurement, then have increase, 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 decrease, increase, 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 decrease, increase. Which means that in this example there are 7 measurements that are larger than the previous measurement. How many measurements are larger than a previous measurement? And then we have our puzzle input. So this first day is usually much simpler than other days. So they start off simple and then they will be more complex, of course. But let's jump over here. I have started off by downloading the inputs and also just check that the actual compiler works. I will run JDK 17 for these exercises, but it doesn't really matter what you want to run with. If you want to follow along, run your own. But I'm gonna try 17 for this. Maybe use some 17 functions if I get the chance. I don't really know. So let's see here. First off, I have this puzzle input here. If I want, I should be able to make this kind of a thing. Is that a thing now? String data. Could that be a thing? Do we have that yet? Or is it just 2 that we need? No. I thought it was 3. So what's the problem here? Legal text block starting and so that's a thing now. we can have text blocks. How much fun it is to write. So here I would like to take the data. So let's do a string s from data split by new line. Let's do that and just output that, see if that works. And print out s. Let's see what we get. If we get what I expect. Yes, we got all those lines. We don't need the first line here, that's not important. And it seems like we got an extra line down here, so the text block could actually end with these characters, but they could not start with them. Or it doesn't really matter, we got the same result here. Okay, so now we have the numbers. So if s is blank, then continue. So we will skip any extra lines. Will we miss the last one? Yeah, probably we didn't get one down there. Anyway, and then I want to get each number. So integer I, just int I, because we know that they are integer numbers. Or do we know that? We can look at the inputs here for this day. It seems like they are all in integer numbers. So let's just make it easy for ourselves. So let's take integer, parse int, and this string. And then I want to have int count. So how many times count decrease. And then int last num. Let's set that to -1. So here, if last num is equal to -1, then last num is equal to I. Else, if last num is larger, or let's say if this new number is larger than last num, then we will set last num to the new number and take our count, increase, right? Increase. So how many times it increases? So we will count that, and then we will have a count increase and print that out. So if everything is correct here, we would get 7, but we get 5 here. So why do we get 5? So last number is 1, then we will set it to something else. So let's look at this. Did I do anything wrong here? So here we have it. So the first number is 199, and it's not equal to 10, so we set it to that number, and then jump up here, we get 200, and it's larger, so we will increase. Next, we will get 208, it's larger, so we will increase. And then we will get 208, which is not, yeah, it's larger, yeah, 210 we got. And then we get 200, which is not larger, so we jump over that one, 207, which is, oh, so the last num is something that we set every time. Okay, that changes things. Yeah, so if it's, then we just need to do this kind of thing. And here we continue. So in the first case where we don't have any number, we just set the number and continue, which makes it run one more time. Otherwise, we will see if it's larger, then we want to increase it. Otherwise, we will just set the previous number. So let's see if we got the right number now. Yes, now we get 7. So now we know that our function works with a test data. So now we only need to write something that can give us our actual data. So let's do a buffered reader. BR equals to a new buffered reader. And it will have a new file reader, which will take the input / input day1 txt. And I believe there is newer, fancier way to do this, but I just don't know them. So that's something that I need to learn as well, so I will get improvement in my coding style here. But let's just start with something that I know, and if you have any suggestions, you know where to put them down in the comment section down below. So we learn together here. BR readline, and I usually do this like string line equals to not set that one, and then I do while loop if line equals to BR line is not equal to null, then continue, and then I can move these things up like that, and then we just replace s with line here. So that's pretty much the only thing I need to do. Then I can run this example, and we should not get this kind of issue. So we have inputs day1a. Yes, good thing that we catch the error here. So what I did here was I put it into try catch, where I print the stack trace down here. You could also throw the exception right off the function. So 1521, could that be the right one? We validated that the function did the right thing with our test data, but will it do the correct thing with the actual input data? Let's try it. And yes! You get a gold star, I get a gold star, everybody gets a gold star. That was the right solution. So we are off to a great start. And there's a part 2. Considering every single measurement isn't as useful as you expected. There's just too much noise in the data. Instead, consider the sums of 3 measurements in a sliding window. Again, consider the above example. So we have AAA, BBB, CCC, DDD. Starting by comparing the first and the second 3 measurements windows. The measurements in the first window are marked A, 99, 200, and 208. Their sums are 607. The second window is 200, 208, 210. Its sum is 1618. The sum of the measurements in the second window is larger than the sum in the first, so this comparison increased. Your goal is now to count the number of times the sum of measurements in the sliding window increases from the previous sum. So compare A with B, then compare B with C and C with D. Okay? And so on. Stop when there aren't enough measurements left to create a new 3 measurements sum. In the above example, the sum of each 3 measurements window is as follows. So we have here that We have an increase, no change, decrease, increase, increase, increased. So there are 5 sums that are larger than the previous sums. So that was the example that we got if we did our wrong calculation. Consider the sums of a 3 measurement sliding window. How many sums are larger than the previous sum? Okay. So, in this example, I think that what we want to do is have a start value. So let's say that we want to read 2 values before we actually do anything. So, and after we have done that, we can add the 3rd value, and that should be our sum. And then we will need to compare that with the last value. So int start count 2. So if, let's see here, if start count is larger than 0, then we take start count and do a minus of that, and we will increase last num with I. Will this work? Because we need to remove the previous value as well. So that will not work. Probably. So last num current equal to, we add to current, so we will have int current as well, and if start count is less than 2, then we add the current. So now we have done the start operation here. If we run this again, if we comment this one out and then do a for loop of string s of data split over lines, like that, and we can call this line again, so we don't have to swap back and forth. If we do that, we should be able to test this and see what values we have in our current and our last num. So the last num after these two are the addition of 2 values. No, we need to have a 3rd value as well. So let's do that. Let's run this. Oh, not run this. We need to calculate. So now we are down here. So now we have added 3 values. So the last num was 606, right? No, that will not work. That will not work. Let's do this as small arrays instead. Three values, int, three values. New. Let's see here. So, current 0. Or will it work? No. So current, let's do start count less than 3, start count larger than 0, and then start count -1, and last num is start count. So now we should have arrays instead here, down here. So what I'm trying to accomplish here is to save all the values that will be written. So I will have the last 2 values in one array and the last 3 values in one array. So now we see that we have in the last num 99, 200 and 208. We will have 200 and 208 in the current. So that's great. Here we can take current and the second value and put I into that. Now we can do a calculation of these 3. Let's do this simple. Don't want to make this a hassle. Another language would probably have something much easier to work with. But I'm just going to make a little bit of a for loop here. Last numbers, current numbers, just to make it easy. Last numbers, current numbers. There we go. Int current, just cur, int last, and then we do last equal to last numbers j, add that one, and we do the same for the current value, current numbers. Now we can have this comparison. If the current number is larger than last number, we'll print that out. And now we need to do a switcheroo. So we will have another one of these for loops. What we will want to do here is the last number should be equal to the current number j plus 1. And we want to do only 2 steps. And the current number afterwards we want to be the same current number plus 1. And no, we want current numbers to be last numbers, right? And we want to switch so here we want to do an arrays copy of these, so we don't int what new length, okay, 3. So that should make a new copy of this with a length of 3. And then we just switch this up, and hopefully the current numbers will be added up there again. So let's try this out. We will start over here. So let's see. We go in here. We have the 2 arrays that we expect. We get the next number. We go through and calculate these large values. So we have 607 and 618. I believe those were the right numbers, right? 618 and 607, yes. And then we will increase the count. We go down here, we will copy last numbers. So we will get all the values of the other one. And then we will switch this one out. So we will move the numbers around. We'll fetch a new number, put that into the last place there. And we will count these again. And if we go down here, we should have last number 618, this number 618, and that's no change. So it seems like we have the right algorithm now, and if we get 5 as a result, looks very promising. And if we go here again, we will comment out the other lines. We go from the test data to the real data and run it here. We will get 1543. Let's go here and enter that value. Let's hope it's the right value. Let's see. Yes! You get a gold star! I get a gold star! Everybody gets a gold star! We solved day 1. So let's go back and see what we did. We first off wanted to test everything out. So we have this test data, and now with the fancy new functions that we have in 17, we're able to use string, multi-line string thing. So we have all those values there. And then we had a buffered reader to read the other numbers. We had something where we counted all the values we wanted. We had 2 windows, one window with the last numbers and one window with the current numbers. And in order to fill them up with the first numbers, we had a little of a start count, so we got things rolling. We have this little thing to read line by line. And here we will read one line until we get null back. That means that there we are at the end of the line, end of the file. We will skip every blank line if there is any. We will interpret each line as an integer. And then if we have some startup to do, we will fill our little count here. And if it's not the last value that we want to put in, so the values 2, 1, and 0, then if it's not the let's see, if it's not the first value, because that value we don't want. So if start count is larger than 0, so we skip the first value, but if it's larger than 0, then we will pick that value and put it into the 0th position, or the 1 position in our array. So the first 2 values will go into the current numbers, and then we will just fill up the last numbers. So first and second and third value will go into last numbers, and we will increase our start count. So this little function will fill up the multiple arrays with the first one, the last numbers, 3 numbers, and the second current numbers will only have 2 values, the last 2 values. Then we will put the last number that we want in the sequence, so the 4th number, if we just start from the beginning, the 4th number will go in position 2 in the array, so 0, 1, 2, the second position in the current numbers array. So now we have all numbers, we have the previous 3 numbers, and this except the last number, and the previous 3 numbers except the first number in the sequence. And then we will go through here and add them together, current and last, so we will get the summation of these 2 arrays. And then we will run a little if statement here and increase this count. I guess this could have been a small function of, let's say, a reduce, but it's so small numbers, so I think this was a faster way to do it. Then I will copy the full current numbers over, because we want a new last numbers, which is all the 3 numbers we have seen last. And then I want to switch over which numbers are in the current numbers. We will get an empty place where we can put the next number into, except we will not empty that place. It doesn't really matter. And when we have done that, we will go on to the next value, and we'll do that until we don't have any more lines to read, and we will print out the count that we increased during this little calculation. So this was the first day, and I hope that you found this interesting. I hope that you learned something today. Did you solve it in a different language, or did you solve it in a different way? Please leave a comment with some code, and I will gladly read it and comment about it. I love reading others' code. It's the way I learn, to look at how others solve solutions. And if you think that I could improve my code in a significant way, then either create a PR for the repository, I will push this code, or leave a comment and I will try to improve until day 2. I will do this as long as I can manage and release one video each day. And if you like this video, give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that. And I really hope to see you in the next video.